Humanity has long wondered what worlds might lie beyond our own, and what mysteries they may hold. In 1995, this curiosity led to the first detection of a planet around another star, giving birth to the field of exoplanetology, the study of extrasolar worlds. Since then, over 4,000 exoplanets have been found, and we've learned interesting things about many of these, such as this fascinating world, which has a ring system larger than Mercury's orbit, and evidence suggests it has at least one moon. But how do we study something so far away? Thanks to human ingenuity, we have many tools and methods. This is TESS. It monitors the light from stars to find exoplanets, such as this one, which is similar in size to Earth and orbits in the habitable zone of its host star, a Class M brown dwarf. The habitable zone of a star is the region where orbiting Earth-like planets could maintain liquid water on their surfaces. All 3 planets of the TOI 700 system have orbits which pass directly between the Earth and their star. They eclipse some of its light, causing dips in the star's brightness, or luminosity, known as transits. TESS and other telescopes are used to record stellar luminosity. Plots of this, called light curves, are analyzed to find possible transits. Researchers then check for glitches, companion stars, or any alternative explanation for the apparent transit. If there aren't any, it's considered an exoplanet candidate, which can then be confirmed by a different method or verified by another telescope. It's remarkable just how much transits tell us about a planet. The interval between transits is the planet's orbital period. Using Newton's version of Kepler's third law, we can find the planet's mean orbital radius, giving us a circular approximation of its orbit. The mean orbital radius is equal to the cube root of the orbital period squared times the product of g and the stellar mass divided by 4 pi squared. Often a planet's mass is determined using other methods, but if there are multiple transiting exoplanets in a system, their gravitational interaction may alter their periods enough to estimate their masses. A planet's radius is the product of the star's radius and the square root of percentage of light blocked during a transit. From its mass and radius, a planet's density can be found, telling us whether it's rocky, gaseous, or some other type. If the spectral lines from the absorption of light by an exoplanet's atmosphere during transit are detected, this may reveal the atmosphere's composition.